Hello, my name is Connor Phelan, and I'm joined by my partners William Lynch and Raul Medina Charlie. Today we will be presenting a detailed technical overview of the bubbling fluid bed power plant, which is also a BFB power plant. This technology has revolutionized how we handle difficult fuels such as high moisture biomass and waste products. During this presentation, we will cover the system's overview, operational principles, practical applications, environmental concerns, and the future of the technology. Looking at this system, the diagram represents a complete scale of the bubbling fluidized bed boilerplate. We can break this down into three main sections: the furnace section, we then have the steam cycle system, and then the exhaust recovery system. We can start by looking at the sand fill chute, which is located down here in the bottom of the furnace section. And this is used to maintain our bed inventory, which is supplied by the fuel chute right here. And the fuel chute is used to drop the biomass directly into the bed. We then utilize bubbling caps, which are right below the sand fill chutes, which allows fluidized air to be pumped through the supply duct at the bottom passing. And these caps are used to create the 1.5 meter per second bubbling motion required. We then utilize startup burners, which are located right here, and they are used to preheat the sand. We move up the furnace to the lower and upper OFAs, which are these green ducts right here, and by not putting all the oxygen in at the bottom, we are able to control the combustion temperature and prevent the formation of thermal NOx. We also utilize flue gas recirculation to further cool the combustion zone and improve the efficiency. Once the flue gas has left the furnace, it passes through the superheater, which is located right here, and the boiler banks. This is where water is converted to high pressure steam, which is in the steam drum, which is right here. And to maximize every BTU, the gas is then flowing through a 3-module economizer right here and is used to preheat the feed water and at an air heater to warm up the incoming combustion air. By the time the gas leaves the system, we've extracted the maximum possible energy to ensure high plant efficiency. This schematic we see is the bubbling fluidized bed reactor, and it is the heart of the BFB. This process begins with biomass right here being inserted into the feed hopper. The feed hopper then utilizes a feeding screw, which is a critical component since it provides a mechanical seal and pressurized meeting of the biomass, ensuring a consistent fuel-to-air ratio within the furnace. Following the airflow at the bottom right here, the air is forced into the system and passes upward through the grid right here. This is where the bubbling occurs, and the air velocity is tuned precisely to lift the bed material, creating a turbulent liquid-like state. This motion is what allows for such high efficiency combustion, and the air is aggressively mixing with it in 3 dimensions. In terms of heat transfer, this system is unique since the fluidized bed consists of hot turning solids. The fuel particles are subjected to constant physical contact with the bed material, and conductive transfer allows the thermal reactor to maintain a stable combustion temperature between 800 and 900 degrees Celsius, even when handling difficult fuels with high moisture content. As the biomass breaks down, the resulting hot product gas and finer particles rise to maintain the system's efficiency. We then use a cyclone on the right here. Using centrifugal force, the cyclone spins the solids out of the gas stream, allowing clean product gas to exit the top right here, and leaving the ash to flow through the bottom and be back into the system. The ash is then removed by the ash removal screw and then out through the ash right here. This continuous loop ensures the bed inventory remains clean and that the heat transfer surface remains effective.
Hello everyone, my name is William Lynch, and I'm going to be doing the application and versatility of the bubbling fluidized bed power plant. So the fuels they can burn a wide range of fuels. The fossil fuel route is coal, and then some biomass fuels they can burn are wood chips, bark, rice husk, coffee husk, and even cashew shells. They can also burn paper mill sludge, which is good, turning that waste into energy. And they use a process called RDF to do this. So it's called refuse derived fuel. It's a renewable energy product created by processing industrial waste specifically non-recyclable paper, fibers, wood waste, and plastics into a high calorific solid fuel. And that's the nice thing about these power plants is that they can use fuels with up to 60% water content because they use a high temperature bed of sand that dries and ignites the fuel before significant heat loss occurs. The bed consists of sand, ash, and fuel maintained between 700 and 1,000 degrees Celsius. Um, and like I said, when wet fuel enters, this high temperature immediately dries the fuel and initiates combustion. All right, now we're going to be taking a look at the environmental concerns. So we're looking at the environmental impact of the bubbling fluidized bed boilers. The fluidized bed is really good because we can operate at much lower temperatures than traditional boilers, which naturally prevents the formation of NOx. We can also solve the sulfur problem inside the furnace by adding limestone, which captures sulfur before it can even become an airborne pollutant. These also use baghouses and ESPs, which are electrostatic precipitators, to catch particulate matter. So an ESP works by uh, high voltage wires, giving the dust particles a negative charge, and then these charged particles then stick to positively charged plates. And then there's mechanical devices called wrapping, and it vibrates the plates and it knocks the debris off, and they can go into hoppers, and that allows for clean air to exit the stack.
Alrighty, so the future for the bubbling fluidized bed reactor. Um, it's a leader in waste energy because it can handle fuels that are typically difficult to use, or rather we don't use, like wet biomass or mixed wet streams, which are usually inefficient in normal systems. But this technology was specifically designed to be able to use these effectively. This makes it versatile, for one, and valuable in conditions where the optimal fuel isn't readily available or isn't ideal for the situation. One of the big benefits is that it requires very little retrofitting for existing plants. So instead of building an entirely new plant for this specific type of power production, we can convert existing coal plants to make them pretty much 100% biomass. This makes the costs go way down, and it significantly improves the rate at which we can produce renewable green energy. Hydrogen production, which turns waste into clean syngas and hydrogen. And hydrogen is good for the future because it's clean. Although the production of it produces CO2, this is one of the more greener ways to actually produce it. So it'll be useful, decades from now as well. It's well suited to more localized power generation, so industrial parks, rural towns, and in locations where it wouldn't warrant a large scale power plant, you would rather build one of these so that you can still have power, but it won't cost as much. It'll also help with your independence or your energy independence. These are, since they're so futuristic, the controls for these systems are mainly AI based sensors. These, monitor fuel quality, automatically adjust all the systems they need to improve their or to continuously maintain a positive efficiency and keep emissions low. Alrighty, so in conclusion, the bubbling fluidized bed reactor is flexible, energy and energy efficient form of energy production. It enables stable combustion, has great heat transfer performances, can burn wide ranges of fuel. It can handle highly moisturized and low quality fuels. It has better NOx emissions or lower NOx emissions. It employs limestone capture for sulfur and multiple different types of filters for particulates and CO2. And it's a great option for your waste to energy. And it will help improve greenhouse gases. Yippee.